Welcome to a video on determining the trigonometric function values using the unit circle. I would recommend that you watch the video on how to find trig function values using reference angles and reference triangles first. So before we jump to the unit circle, let's take a look at our reference triangles. Remember, if we have a 30, 60, 90 right triangle, the sides of the right triangle relate in a special way. We could label the short leg 1, the hypotenuse 2, and the other leg square root of 3, or any multiple of this. And for the 45, 45 right triangle, we could label the two legs 1 and the hypotenuse square root 2. Now just to refresh your memory, when we have the unit circle, what that means is the radius of this circle is equal to 1. So if we sketch an angle in standard position and sketched our reference triangle, the hypotenuse of this triangle would equal 1 unit. So going back up to our reference triangles, if we were to take the hypotenuse of this triangle and make it equal to 1 by dividing by 2, we can do this as long as we divide everything by 2. Of course, 2 divided by 2 equals 1. This would be square root 3 divided by 2, and this would equal 1/2. These are the values that we'll see on the unit circle because the hypotenuse of the reference triangle corresponds to the radius of the unit circle. On this other right triangle, if we want the hypotenuse to equal 1, we'd have to divide by the square root of 2. And what we'll see now is the hypotenuse is equal to 1. If we rationalize this, we would have the square root of 2 divided by 2 in both cases. And these are the values that we'll also see on the unit circle. So let's go ahead and take a look at the unit circle. What we can see on this unit circle are the labels of the most common angles in standard position for us. Keep in mind that the radius r is equal to 1. So what that tells us is that the x-coordinate is equal to cosine theta, and the y-coordinate is equal to sine theta, and of course tangent theta would equal y over x. So let's go ahead and use this to find some trig function values. So what we have to figure out is where does the terminal side of the angle in standard position intersect the unit circle. Let's go ahead and sketch this angle and see. Because it's negative, we'll go clockwise 150 degrees, so there's negative 90, and negative 60 more would be here. So this is the point on the unit circle that we can use to determine the sine of negative 150 degrees. Remember, sine is equal to y, so we have negative 1/2. Let's take a look at the cosine of 960 degrees. For this angle, I'm going to go ahead and find a smaller coterminal angle. So if I subtract 720 degrees from this, remember that's like 2 revolutions, I would have the cosine of 240 degrees, which would equal the cosine of 960 degrees. Let's go ahead and sketch this. So from here to here would be 180, and we need to rotate 60 degrees more to here. The terminal side intersects the unit circle at this point. Remember that cosine theta is equal to x. So it looks like we have negative 1/2 again. Now let's look at tangent 180 degrees. So again, here would be the initial side. We rotate counterclockwise 180 degrees. Here's the terminal side. So we'll use this point to determine the tangent of 180 degrees. Remember, tangent is y over x, so we have 0 over negative 1, which is equal to 0. Let's go ahead and take a look at a few more. Now we want to find the cosecant of 225 degrees. Let's sketch it. We can see it labeled here. There's the terminal side. So we can use this point to determine this value. Remember that cosecant theta is equal to the reciprocal of sine theta, and sine theta is equal to y. So we want to take the reciprocal of negative square root 2 over 2, which would be negative 2 over square root 2. Let's go ahead and rationalize this. We would have negative 2 square root 2 divided by 2. To simplify, we have negative square root 2. Next we have the secant of negative 240 degrees. So we'll go clockwise. There's negative 180. We have to go negative 60 more to here. So here's the terminal side. We use this point to determine this value. Remember that secant theta is reciprocal of cosine theta, and cosine theta is equal to x on the unit circle. So the reciprocal of negative 1 over 2 would be negative 2 over 1, which of course equals negative 2. And the last one, we have cotangent 540 degrees. So let's go ahead and sketch this. There's 360, and if we subtract 360, we would have 180. So we need to rotate another half of a revolution to here. Again, we're doing this to determine where the angle intersects the unit circle. We use these coordinates to determine this value. Tangent theta is y over x. So cotangent would be x over y, negative 1 divided by 0, which is undefined. So that's how you can use the unit circle to determine trig function values. I hope you found this tutorial helpful.